Hello, so in today's video we're going to have a look at acceleration and velocity time graphs. Now please make sure your phone is off, any other tabs on your computer are closed, you've not got the TV on or anything in the background to distract you, and you do have your pen and paper or your booklet with you. You might need a calculator as well for this session. At times you may see this yellow banner appearing. At that point I would like you to pause the video and complete the task on screen. You can pause the video now to make sure you are ready to start learning. So let's begin. So we'll have a little look first at what is acceleration, just a quick recap. So acceleration is the rate of change of velocity, or it's speeding up, we could say. It's how fast something is getting faster. And we measure it in meters per second, or meters per second squared. So it's the rate of change of velocity, how fast we are getting faster. So how fast we are getting faster. Or it could be slower as well. We can have deceleration. That is still a form of acceleration. And remember, we can calculate acceleration with the following equation. So acceleration equals change in velocity divided by time. We need to make sure we always have our correct units as well. So this is meters per second per second. Our velocity is in meters per second, similar to speed, and our time is in seconds. So, velocity time graphs. Quite simply, they are graphs that show velocity on the y-axis, that is this one here in meters per second, and time on the x-axis, the one going along here. And we can get a lot of information from these graphs. You might remember looking at distance time graphs in the previous lesson. If not, go back and have a look at that video as well to remind yourself. So we're going to have a look at what a velocity time graph shows. And it can tell us a lot about the velocity of an object over time. A distance time graph told us something about the distance. We could infer things about the velocity from the gradient. A velocity time graph tells us about the velocity of an object over time. And the gradient of the graph will tell us the acceleration. Just like a distance time graph, the gradient told us the velocity. We've got our graph here. We're going to show some lines and see what they mean. So a line that is going straight across, a horizontal line, shows a constant velocity. We can see that our velocity, whatever number we would have here, isn't changing, and we're just going at a constant velocity. Our one here, this line that is going up, is an acceleration. Our velocity is increasing. We're getting faster. So we are accelerating. This yellow line here, we are accelerating faster. We're going faster than this one. We're getting to a higher velocity quicker, so we're accelerating faster. And our last one, we've got the line going down. So going down shows us that we are decelerating. We started at a high velocity and we've decreased our velocity. We've got slower. We call that decelerating or deceleration. So I'd now like you to pause the video and complete this table in your booklets that compares distance time graphs with speed time graphs. When you're ready, you can press play. You should have now completed this table. We'll go through the answers. So a distance time graph. This horizontal line here shows us we have zero velocity. We're not moving. The distance hasn't changed. You can see that on a speed time graph or velocity time graph, we have a constant speed. Looking at this next one, our line is going up at a constant rate, so we have a constant velocity. We are going at a steady velocity. We're not changing it. That's why it is a straight line. If we saw that on a velocity time graph, we would say that that is a constant acceleration. Now, on our velocity time graphs, if we have a steeper line, that tells us we have a higher velocity. The steeper this line is going up, the higher the velocity. On a speed time graph or velocity time graph, it is a higher acceleration. On a distance time graph, our gradient equals our speed, and on a velocity time graph, our gradient equals our acceleration. Now, this last one down here, you might be like, oh, he hasn't told us anything about that. That didn't come up at all. I didn't on purpose. I wanted to see whether you'd be able to work it out and have a think about it. So, absolutely fantastic. Well done if you did. If not, don't worry. I'm not expecting you to know things you haven't been taught. But the area underneath a speed time graph, so underneath this line here, or this line here, will tell us the distance travelled. So it can be very useful for working out distance and speed from these speed time graphs. Or distance and acceleration, rather, from these speed time graphs. So we're now going to have a look at working one out. So we're going to calculate the acceleration and distance on this graph. I'm going to talk through it first, and then we'll have a go at doing one. So first off, to find my acceleration, I need to find my gradient. So it equals my gradient. My gradient, hopefully you remember from your maths lessons, is my change in y divided by my change in x. You'll notice how I'm writing out what I'm doing for each step. So first off, I'm going to work out my change in y. I'm going to look at where this value is here and my value down here to see what my change in y is. So I've gone from 6 up to 8.5. So we've got 8.5 and 6. So my change in y equals my value at this end, so at the right end, so 8.5 minus my starting value of 6, which equals 2.5. I'm now going to work out my change in x. My change in x, I'm starting here, which is at 10, and it's going to go all the way back over to there and get it to 0. My change in x, going from the value on the right first, is 10 minus 0 equals 10. So nice and easy. 10 take away nothing is 10. Almost wrote 0 there. Don't tell anyone I did that. So I can now work out my gradient. So my gradient, or my acceleration, which I'll be working out, is my change in y, so 2.5, divided by my change in x, 10. If I do that, I'll use a calculator for that, and I get 0.25. And that means my acceleration, just having the gradient isn't enough, I need to get my units in as well, is 0.25 meters per second squared, or meters per second. You might remember saying we need to work out the distance as well, and the distance is the area under the graph. You might be thinking, how do I work this out? It looks really, really tricky. Quite simply, we can break it down into two different shapes. We've got one down here, which is a rectangle. And then we have this part here, which is a triangle. So our rectangle's area is the length times the height. So our length will go all the way from here to here, so from 0 to 10 is 10, and our height is going from 0 up to 6, which equals 60 meters on this point. So that is my area in this rectangle part. I then need to do my triangle as well. In case you've forgotten working out the area of a triangle, it is half, or 0.5, times the base times by the height. So I'm going to have half times by my base, which is 0 to 10, so 10 times by my height of 6 to 8.5, which is 2.5, that distance there. So I'm going to have my triangle, or my rectangle will do first, which is 60 meters. So we'll bring that across to there, times by my half, plus, that should be, plus 0.5, times by my base, which was 10, times by my height, which is 2.5. It's just the height from where the triangle bit starts. I don't go from the bottom up to there, I just do this bit here. So that's 6 to 8.5. I then work this out. Again, I use a calculator. So I get 60 meters plus 0.5 times 10 times 2.5, which gives me 12.5. If I add them together, I will get 72.5 meters. So there we have worked out the acceleration and the distance. We're now going to have a go at doing one together. We're going to work out the acceleration and the distance. So try and do it with me. Try and move ahead if you can. If you need the help, do watch the video. So our acceleration equals, what does our acceleration equal on this graph? That's it, well done. It is our gradient. And our gradient, how do we work out our gradient? Yes, that's it. It's change in y divided by change in x. Well done. So we're going to work out our change in y first. So our change in y, we've started at 8 and down to 0. That equals 8 minus 0 equals 8. Well done. And our change in x, well, it goes up to 6 seconds here, so that's 6. So we can just say equals 6. That's right, well done for stopping me. You have realised that it starts at this point here, so at 2 seconds. So actually our change in x is from 6 to 2. Our change in x is 6 minus 2, which equals 4. So our gradient equals our change in y of 8 divided by our change in x of 4. 8 divided by 4, I'm doing my calculator just to make sure I definitely get it right, is 2. Therefore my acceleration equals 2 meters per second squared, 2 meters per second per second. And next up, we're going to work out the distance. And the distance is, how do we work out the distance on these graphs? That's right, well done. It is the area under the graph. Now, we had to do the rectangle. I've not got a rectangle here. That's great. All it means then is I have to work out the triangle. So my triangle is half, or 0.5, times by my base, times by my height, which again equals half, or 0.5 I'm doing it on a calculator, times by my base, which is 2. We're starting at this point here, up to 6, which equals 4, times by my height, I'm going from 0 all the way up to 8. Do that on my calculator. I do 0.5 times 4 times 8, and that gives me 16 meters. So these are my two answers. Well done for doing that with me. Now you've guessed it, coming up next is you are going to do some by yourselves. Give them a go, do them through just how I've done them, write everything down and you should be fine. Make sure you know what we're doing in each step. So have a go at this one and please pause the video and have a go at doing it. When you're ready you can press play. The answers are on the screen now. Pause the video to check your own answers. We'll then move on to the next graph. Again, please pause the video and calculate the acceleration and distance. You should have now completed it. The answers are on the screen. Check your answers now, see how you've done. Very well done if you've got it right. Do another few. I notice on this one, so you don't forget, we have the rectangle here we need to calculate. Please pause the video now and calculate the acceleration and distance. The answers are coming onto the screen now. You can check your answers. Well done if you got that right. This was definitely a trickier one. We'll do one more. This is a deceleration, so our acceleration is going to be negative. You can pause the video and calculate the acceleration and distance. Well done. Let's check your answers. So we've got that minus sign in front of the acceleration because the graph is going down. Distance we still work out the same way. Well done if you got all of those right. If not, do go back and watch the video again. Alternatively, you can send me an email and I will try and help you. Thank you very much for watching. Now don't forget to subscribe to the channel. I'm very sorry this was a much longer video than normal, but I hope it has been useful for you. Have a great day and do stay safe. Take care. Bye-bye.